class, welcome to lesson number 31. We're continuing our concepts in macroeconomics at this point in time. Last class, we went over unemployment and we talked about the labor force, how we calculate unemployment, what types of unemployment there were. In fact, that was the homework question. So you have the answer to the right. There are 4 types of unemployment. Starting off the frictional unemployment. What happens in the frictional unemployment is that a person is coming into the labor force or is in between 2 jobs, okay? Either they got fired or they quit by themselves, okay? Either way, they count as frictional unemployment. So it's not that harmful for the economy. What is though is structural because what happens is that there's a fundamental change in the economy, and what tends to happen is that a job skill set is no longer required. So the labor force is actually eliminated. So for that reason, we counter it with government training programs as well as universities to make sure that you have the skill set to take the right job. At the same time, we also have a seasonal unemployment. What happens is that each season there's a different type of jobs that are required or they're eliminated. Okay, depends on the season, pretty straightforward. Lastly, cyclical. Cyclical unemployment depends on the business cycle. So if there's a recession, things are going bad, more jobs are eliminated. As things are going up, there's less jobs being eliminated, so unemployment goes down. Okay, so 4 types of unemployment. Know this for sure. I probably bet you're probably going to see this on a test, so make sure you know that. All right, so that being said, let's start off with the new stuff. I think we talked a little bit about the consumption function, but for this class, let's start off with actually calculating a consumption function. Okay, to my left here, I have a table, right? You have disposable income, consumption, and saving, okay? Disposable income at this point A is 0, consumption is 40, savings is negative 40. Similarly, disposable income is 100 here, consumption is 120, saving is negative 20. Okay, so how do we get a consumption function? It's based on these data points, okay? First of all, let me give you the equation for a consumption function. Consumption, okay, is equivalent, okay, to, I have this equation here as well, but the MPC, okay, which we'll talk about a little more in detail, which is the marginal propensity to consume, okay, marginal propensity to consume, okay, times the disposable income, okay, times the disposable income, plus the autonomous saving. Put it down as autonomous consumption. Autonomous consumption. All right, so consumption is equal to marginal propensity to consume. Okay, what is marginal propensity to consume? It basically is the percentage, okay, the amount, okay, that you're going to consume, okay, out of your disposable income. Let me give you an example, okay? You have $100, right? You're consuming 120 out of your $100, okay? So your MPC is obviously going to be higher, but understand that don't set it off of one data point. You got to base it off of a whole lot of things, okay? So the way we have done, come up with the marginal propensity to consume, the percentage of the amount of that you're going to consume of the disposable income is that, let's take this data point, okay? You have, at this point, you're making $100, okay? And you're spending 120, okay? Obviously, you're taking money out of the bank, all right? So you set 120, okay, equivalent to 40, because 40 is basically the point at which you're spending. This is called autonomous consumption, guys, by the way. If disposable income is 0 and you're consuming something, that's the amount is autonomous consumption, all right? So basically you plug into and you have an equation, all right? And you basically solve for x like any other mathematical equation. And you get MPC, which is 0.8. Okay, how do you get that? How do you get 0.8? Well, y equals mx plus b. Okay, pretty simple, straightforward. All right, so if my consumption is 40, my DI is 0, okay, my autonomous consumption has to be 40. Okay, autonomous consumption has to be 40. All right, so now I know some things, okay? I know that my B is 40, or my autonomous consumption is 40. Okay, my new point consumption is 120, okay? DI is 100, so I plug that in, and I want to know what the MPC is. You just solve for MPC, you get 0.8. You solve 0.8. So you get the equation, and you create the consumption function, okay? And the consumption function for this particular data point is pretty simple and straightforward. It is as follows. We said that consumption, okay, consumption C is equivalent to the autonomous consumption, whereas where disposable income is 0, we find autonomous consumption, 40, okay, plus the MPC, which we solved for, is 0.8 times the disposable income. Okay, so that's why when we graph a consumption function, all right, we start with the intercept 40, and we make that constant slope of 0.8. Okay, so hopefully it should be pretty straightforward how to create a consumption function at this point. One other point to note, guys, is that your marginal propensity to consume plus your marginal propensity to save is equivalent to 1. Okay, is equivalent to 1. All right, so that is the most important. If you guys wanted a definition for marginal propensity to consume, it's that it's the change in consumption caused by a change in disposable income. Okay, the change in consumption caused by changes. So if my disposable income changes by 100, okay, here it's gone up by 80. Okay, so the change is 80, okay, over 100, and that's why the MPC in this case is 0.8. So the marginal propensity to consume, again, I'll say this again, is a change in consumption, okay, caused by a change in disposable income. Similarly, okay, MPS is marginal propensity to save, is the change in savings caused by a change in disposable income. So my disposable income changed by 100. In this case, in my savings, it went down by 20. Okay, so 20 over 100 gives me 0.2, right? Which I could have solved because MPC plus MPS is 1, MPC is 0.8, okay? MPS has to be 0.2 for it to equal 1. All right, so at this point, let me erase the board. So one more time in a formula, if I'm not clear, I'm going to go over MPC and MPS one more time because we understood a couple things. Okay, I'll tell you why MPC and MPS are important. Okay, MPC, all right, we defined as, using the formula, we said the change, okay, the change in consumption over the change in DI, right? MPS, we said, is the change in savings over the change in DI. Okay, marginal propensity to consume, marginal propensity to consume and marginal propensity to save. Okay, so why is this important? Well, we use MPC to create a consumption function, right? We said consumption is equivalent to the autonomous saving, right? Autonomous consumption, excuse me, auto consumption, okay, plus the disposable income, okay, times the MPC. And that's why it's useful in making a consumption function. All right, so how do we create the saving function, right? How do we create a saving function? Well, saving function is actually pretty similar. Saving function is the autonomous saving, auto saving. And guys, this is the same thing. Okay, we said autonomous consumption is the consumption at 0 disposable income. Autonomous saving is the saving at 0 disposable income, plus DI, disposable income, times the marginal propensity to save. Okay, so know these for sure. They might show up on a test, and they're going to be important for you to understand. So that being said, let's go on ahead to the fun and exciting stuff that we're going to cover. We're going to talk about what is the determinants of consumptions and savings. Yeah, it's not that interesting, but it's important. So let's talk about, well, I mean, it could be interesting, right? All of you not all of you, some of you might hope that this class in economics actually pays off one day and you can accumulate some wealth, okay? Some money for yourself, all right? So let's start off with that wonderful topic of wealth, okay? So wealth, okay, how does it determine consumption and saving? Well, wealth states that as the wealth increases, okay, consumption increases, savings decrease. Why? Okay, well, wealth, if you imagine, it's not going to be directly in cash. Maybe you're going to buy more houses. Maybe you're going to buy more land. Well, in a time when you need money, you're going to sell that wealth and enjoy that money for yourself. So consumption is going to go up, savings is going to go down. All right, wealth goes up. So what about expectations? How do expectations change things? Let's talk about expectations and how they affect expectations affecting consumption and savings. Well, think about it. Okay, let's say that you expect your future income to actually decrease, all right? To decrease. So if your expectations about your income decreasing in the future are true, right? If you expect your income to go down, you're going to spend more right now, right? You're going to enjoy what you have, and you're going to try to buy the products when you can afford it. And saving goes down, okay? The other one is, what if you say that your income in the future is going to go up, okay? It's going to go up. I'm sorry, I mixed that up a little bit. If you expect the income to go down, you actually consume less because you want to save more, right? You want to prepare yourself for the future, right? Now, if your income goes up, okay, you consume more, okay, because you know that you're going to make more money in the future, and the savings will go down, okay? So understand that. All right, so we talked about wealth, we talked about expectations. Okay, let's talk about our third determinant that affects consumption and saving is household debt. Household debt. Okay, so debt. How does debt affect it? Well, as your as your debt actually goes up, okay, as your debt actually goes up, you actually tend to consume more. You tend to consume more, okay? But what if you have high debt? What if you have high debt? Well, if you have high debt, okay, high debt is going to make your disposable income a lot smaller for you to consume because you're going to use your disposable income to pay that debt, okay? And then you in turn have less consumption. So your consumption actually goes down in a situation with high debt. Last one is taxes and transfers, and it's pretty cool because for taxes and transfers, consumption and saving moves in the same direction. So let's say your taxes are more, you consume less, you save less, your taxes go down, you consume more, save more. All right? So pretty straightforward, self-explanatory, but I wanted to go over these just in case. Okay? Let us start a new topic, and continuing this lines of wealth, we're going to talk about investing. Okay, we're going to talk a little bit of investing. So how do you actually invest? How do you decide when to invest? When is a good time? When is not a good time? All right. So here's how economics kind of guides us towards investment. So on a very, very, very simple level, we're talking about two different things. R, okay, which is the rate of return, okay, and I, which is the interest rate, okay, rate of return, interest rate. All right, so what if your R, your rate of return, is greater than your I, the amount of money you borrowed at? Well, this is an excellent situation, right? Because the investment that you're making is giving you back more money than the amount of money than the interest at which you're borrowing it. Okay? So in this case, you would invest. So what happens if my I, which is the rate at which I'm borrowing, is greater than my R, which is the rate of return of my investment? You don't invest, right? You don't invest because it doesn't make sense. It's more expensive for you to borrow money than you're actually getting back. So it's not an economically good decision. In the real world, people normally shoot for R equals I at first because the really profitable projects go out first, and then the least and less suitable projects that give you less return, rate of return, you invest in, because what tends to happen is after some time, the interest rates actually fall, and so then you get the chance to put in projects that are not with high rate of return. All right, so that's your quick guide to investing. So continuing investments, let's talk a little bit about the graphing investments, which is basically talks about investment demand. All right. So how do you graph investment demand? All right. So investment demand curve looks like this. On your x-axis, you have investment. Okay. On your y-axis, you have interest rates. Okay. Interest rates, and it's a downward sloping investment demand. And why does this work this way? Why is investment demand downward sloping? It's because as your interest rate falls, okay, as your interest rate falls, it's easier for firms to invest in different projects because it becomes cheaper to borrow money. Okay, so imagine at 8% interest, right? Investments are at, let's say, $10 million. Okay, but if this interest rate, right, was lower, right? Let's say this is 5% and this is 2%, okay? At 2%, it's much cheaper by about 3% to like borrow the money. So if it's cheaper to borrow money, right, my investments are going to go up. So I'm going to invest in more and this is going to increase, okay? So investment demand is downward sloping. Just remember that. Investment demand is downward sloping. All right. What about investment itself? What about investment I? We talked about that in the GDP. How does that look like? Well, on the y-axis, we have investment. Okay. On the x-axis, we have GDP. Okay. GDP. And how does that work? Well, it's sort of like a flat line because it's constant. Okay. It's I is equivalent to, let's say, at this point, $20 million. Okay, so investment like that, it looks like a flat line here with investment on the y-axis and GDP on the right. But investment demand has investment on the x-axis and the interest rate on the y, and you basically have a downward sloping investment demand graph. Okay, so that is the basic premises behind interest rates. Investment demand. But what we need to now go into is a market. And the new market we're going to discuss today is called the market of loanable funds, okay? This is something that you're going to have to hear a lot of times from this point on, so I'm going to warn you in advance. Make sure you pay attention to this because we're going to try to go over this first in a very basic manner, and then we'll try to build on it a little later in classes, okay? So first, let us try to explain market for loanable funds. Okay, let me go ahead and erase this. So all of you, when you want money, right, you go to the bank, and if you don't have it in your savings, right, you go ahead, ask for a loan, whether it be education, car, house. Loans are pretty straightforward, right? So what about like understanding those funds? Where do those funds come from? Okay, how does money just come out of thin air? Is it created by banks, the government? Okay. And we talked a little bit about the circular flow model, but we'll talk about money right now in more detail. All right, so basically you as a consumer, right, save money. Okay, we talked about the fact that disposable income has two parts, consumption, right, and saving. Consumption you spend, right, save you put it in a bank account or you put it in a bond, okay? What that happens is this goes to the bank, okay? This goes to the bank, all right? And you basically put your money into their accounts, and you say, hey, as long as you're giving me back interest, you can get to keep the money. Okay. So what the bank does in turn is what they do is they take that money and loan it out. Okay, for houses and cars and whatnot. Okay, or school loans. Okay, so they loan this money, they charge an interest rate, and they make their money back. Okay, and that's how banks make their money. Right? They'll basically loan out your money. So, discussing about the market for loanable funds, let me write that down. Market for loanable funds. Okay, so market for loanable funds. So, what is a market for loanable funds? We said this is the place, right, where all the money that you put into the banks basically gets thrown in here, and also the government savings as well. So market for loanable funds includes two things: public savings, right? public savings and private savings. This is the money that the government saves, and this is the money that you as a consumer save. Okay, so this has both. All right, and let me make sure I get the technical definition to make sure that we're okay on that. Yep, okay, we're good. All right, so let's try to graph it to make more sense out of it. All right, so let's take this, and we're going to have two things, right? We're going to have loanable funds, makes sense, loanable funds on the x-axis, right? And then we have interest rate. Interest rate. Okay? Pretty normal looking graph. We have a demand, right, downward sloping, and a supply a supply, all right? That's upward sloping. And the equilibrium out of the two dictates two things. Okay? The supply of loanable funds and the demand for loanable funds dictates two things. One, if you look at the equilibrium, right, at the y-axis, you see what is the interest rate of the market. So if you go out today, you go to your bank and you're like, hey, excuse me, I want to buy a house, and they tell you, well, sir, it's going to be about 5% interest rate. Well, the interest rate is based off of the equilibrium out of this particular market. The market for loanable funds dictates the interest rate in the market. Okay? On this side, okay, it dictates how much money, okay, can be loaned out, right? The loanable funds market, okay, dictates how much money can be loaned out. This equilibrium dictates two things: interest rates and the amount of money being loaned. Okay? Very important. So that being said, three most important points that you need to get out of this is that first, the supply of loanable funds comes from saving, both public and private. The demand for loanable funds comes from investment. Okay? And the equilibrium is at the real interest rate where dollars equal dollars saved. Well, basically what that's saying is, simply put, it's saying that your saving, okay, your supply, okay, comes from the amount of money you put in the banks and the government has put in the banks, all right? Your demand is coming from the firms that want to take this money and put it in their own firms so they can buy stuff like machines and make sure they can make bigger and better profits, okay? So the demand comes from investment demand, all right? The equilibrium dictates interest rates and the amount of money being loaned, okay? I hope this makes sense. All right, that being said, let's talk a little bit about the multiplier effect. All right, so say you take $1, okay? You take $1, you get $1 out of the bank, all right? You go and you buy M&Ms from the store, okay? So you give the $1 to the store. The store takes the $1, and they in turn spend that $1 on something else. They buy, I don't know, raisins, okay? The raisin people buy raw ingredients. What I'm trying to get at is that the same dollar is being spent repeatedly in different times of the year, different parts of the world maybe. Point is that there's a multiplier effect to the dollar that you spend, all right? So that's why when I spend $1, it's not just affected as $1, but there's a multiplying effect to the economy, okay? The GDP might only count goods and services once, but we cannot underestimate the effect that the multiplier effect creates when someone spends a particular dollar, all right? And we talk about this in a formula, all right? But basically what we're trying to say is that money, right, using the circular flow model, okay, gets spun around and its effect is, you know, quite a couple times more than what it actually is, all right? So never is $1, when I spend $1, is just $1 in the economy. The effect maybe it might be 10 or 20. So how do you know how many times it's being spent, right? How many times can we multiply? Do we multiply 100, a million, a billion? How do we know, right? So we've figured out the multiplier effect mathematically, and it comes down to a formula, right? And on this side, I'll write down the formula, right? So MPC, right, the marginal propensity to consume, right? You remember that? MPC is your change in consumption over the change in DI. Awesome, all right. Now MPS is the change in savings over the change in DI, okay? So using this, let's talk about the multiplier that helps us understand what's the multiplier effect, okay? So the multiplier effect, what is it? right? How do we know? What's the formula, right? Basically, the multiplier is as follows. It's 1 over 1 minus MPC, okay? Or 1 over MPS. Either way works, okay? So this basically says that if I have $1, let's say that MPC in our case is 0.8, okay? I have $1, all right? And let's calculate the multiplier. 1 over 1 minus 0.8, right? That's equal to 1 over 0.2, okay? So when we have this kind of equation, we basically simplify it and we say, well, it's going to be 5, okay? And what that's saying is if I spend $1 in the economy, the effect is going to be 5 times that at $5, okay? So say the government, right? This is especially important, okay, as we later on learn about recessions, okay? What happens in a recession is that, well, unemployment is high, you know, things are not going that well. So how do we change things? Well, one of the ways people change, or excuse me, governments change the economy is by spending more money, okay? In a recessionary economy, governments spend more money. So what they're going to do is if they spend that dollar, what it's going to say is that the effect is actually going to be to $5. So it's excellent, right? The government actually, in effect, creates 5 times the effect, all right? So this multiplier effect is extremely important. So remember that the multiplier, all right, is 1 over 1 minus MPC and 1 over MPS, right? Now, this applies if the government is spending money, G as in government spending, or you spend money on net exports, right? Net exports multiplier. Or you invest money, okay? But what if I have a tax, right? What about tax? Well, tax is a different multiplier because the multiplier that you get out of spending, okay, is much greater, okay, than the multiplier you get out of tax. Because when you tax someone, all right, or you reduce the taxes, people save a part of it, and that saving, okay, does not go back into the economy as much as the consumption does, okay, right? Does that make sense? The savings is shielded from the spending, so only consumption is counted. So tax, in effect, has a little smaller multiplier effect than the government spending, all right? So when they say that, okay, I have a question for you, the government spends about $10, what's the net effect if my MPC is 0.8? Well, you take those $10 times it by 5, which is the multiplier, right? And you get $50, and that's the effect in the economy. All right, so remember that the multiplier effect for now, the multiplier you have to remember for government spending is 1 over 1 minus MPC or 1 over MPS. Okay? So that being said, let's go ahead and review all the things that we've talked about in class today. We've talked about the marginal propensity to consume, right? As you see the formula right in front. MPS, which is the delta S over delta DI. We talked about the determinants of consumptions and savings, right? We talked about investments. We talked about the real rate of return and the amount of which you're borrowing at, which is the interest rate, okay? And if the rate of return is greater than your interest rate, you go ahead and invest in that particular investment. We talked about the investment demand curve, all right? We talked about the fact that it's downward sloping, all right? And the fact that as the interest rates drop, the investment increases. We talked about the market for loanable funds, all right? We talked about the fact that the equilibrium in a market of loanable funds basically creates the interest rate at which we're operating at and the amount of money that's loaned at, all right? And then finally, we talked about the multiplier effect, all right? So that being said, let's talk about the homework question, right? Homework question is as follows. Please go ahead and define me both the, as a formula, of course, the marginal propensity to consume and the marginal propensity to save, okay? And then additionally, I would like you guys to draw me the investment demand curve, okay? The investment demand curve. Thank you so much for joining me. I hope to see you guys in the next class. And in next class, we'll be talking about a lot of things, more importantly, like aggregate demand, how we shift if an economy is bad, like it was in 2008, 2009, how do we change things, and what can the government do to make things a lot better, and so people can get more jobs. All right, guys, take care. I hope to see you guys in the next class. Thank you so much.